In this video, we're going to look at another glancing collision example. Okay, but the information is going to be a little more tedious in this one. So what's happening very simply is that if you look at this left side picture, there's the side view. Okay, you have a 5 meter, you have a block of 0.2 kg mass that moves to the right at 5 meters per second and collides with a 0.5 kg block that is at rest. Okay, now after the collision, this block travels a distance of 0.3 meters along the horizontal when or it lands 0.3 meters from where it started. However, it is not moving in a straight line. Okay, so the top view here will give you a better idea. So in the top view, what's happening is that this 0.2 kg block, okay, is going to collide. It's a glancing collision, and this the 0.5 kg block takes off. Okay, and you should see the distance that it travels is going to be 0.3 meters, and this angle is equal to 30 degrees. So I know from the left side view is a little messed up because it's difficult to realize, but this 0.3 is the horizontal distance that it travels. Okay, it is not the actual length from the edge of the table. Now that would be 0.3 times, I guess, cosine of 30, but that's not what we're saying. The 0.3 is actually the distance that it travels. So understand the picture before you move on to the problem. Okay, so it is a glancing collision problem, and of course our question is to find the velocity and the angle theta of the 0.2 kg block right after the collision. Alright, so let's proceed and do this. Now in order to do this problem, okay, in order to find things that happen in the collision, we first must find the velocity of the 0.5 kg block right after the collision. Now in this case, that information is given in the form of this horizontal distance it travels along a parabolic path. Okay, so we can use all that information of 2D motion to figure this out. What we know is first we need to figure out the time. The time is equal to -1. It will be given by this equation, -1 equals -4.9 delta t squared, which I hope is going to be standard for you guys. And then I think if you calculate this, we've done this plenty of times, so I'm just going to skip a few steps, and we get t equals 0.45 seconds. Make sure you get this. Okay, once we get this, then we can use this equation, delta x equals v x delta t, and since 0.3 is equal to Vx times 0.45, we can get Vx. Vx is equal to 0.3 divided by 0.45, and what this ends up giving us is we get 0.3 times, so it is 0.67 meters per second. Great. So we get the Vx. So we get the velocity of the speed of the 0.5 kg block right after the collision, and now we know that it makes an angle of 30 degrees to the horizontal line. Okay, not to this x-axis, I should call it. Okay, so we have this. Now what we can do is, once again, we can go ahead and use conservation of momentum. So let's use pi equals pf, but let us do it along the x-axis and along the y-axis. Now if I use pix equals pfx, okay, just like the previous problem, in the beginning only the 0.2 kg block is moving, so it has a momentum of 0.2 times 5, and at the end they are both moving, so I have 0.2 v cosine theta, which is the x component of the momentum, plus I have 0.5 times 0.67 times cosine of 30. Great, we have that information. Now let us simplify this. This 5 times 0.2 is 1. 1 is equal to 0.2 times v cosine of 30 plus, so this is equal to 0.29, which ends up giving us 0.2 v cosine theta is equal to 0.71, and which ends up giving us v cosine theta is 0.71 over 0.2, which ends up being 3.55. Great. Okay, so that gives us Pix. Now we can do Piy equals Pfy, and this implies, once again, in the beginning there is no y momentum, so that is equal to 0, and then we have 0.2 v sine theta minus 0.5 times 0.67 times sine of 30. So let us solve this. let's see what we get. We get V sine of theta is equal to 0.5 times 0.67 times sine of 30 divided by, divided by 2.2. And what do we get? So this gives us 0.8125. And now once again we have our two equations, and from we could divide it and get tangent of theta is equal to 0.8125 divided by 3.55, and this gives us theta. If you calculate, so this is about 13 degrees, and once you know this, you can find V is equal to 3.55 divided by cosine of about 13 degrees, 3.64 meters per second. Okay, so that's it for this problem. So once again, we're combining glancing collisions with momentum conservation. What am I saying? With projectile motion and information. The velocities are not directly given, but you've been told something else. So in this case, you've been told how far the object lands. In some other case, maybe you'll be told that it goes ahead and compresses the spring, and all kinds of these things. Okay, so you should be prepared for all these challenges. Just again, if you break things down, life is good. If you are unable to see that, then we're going to have problems. Once again, make sure that you know your projectile motion stuff. Make sure you know all your energy conservation stuff. So those are the things that you're expected to know. Make sure that you are solid at those. Okay, and then everything will be fine. All right, great. I think that's it for this video.